Okay, so this is the last question of this paper. An isolated stationary nucleus X decays by emitting an alpha particle to form a nucleus Y. Nucleus Y and Z are isotopes of the same element. By being isotopes, I believe we can follow that then they have the same number of protons. This nucleus Y and Z are isotopes. So by being isotopes, they have the same number of protons. By comparing the number of protons in each nucleus, state whether the charge of nucleus Y is less than, greater than, or the same as the charge of nucleus Z. So nucleus Y and nucleus Z, we said that they are isotopes. So if they are isotopes, the charge of the nucleus, since the neutrons which are found in the nucleus do not have charge, it's only the protons which have charge. So the charge of the nucleus depends on the protons. So since they are isotopes and they have the same number of protons, they will have the same charge. So we are asked to compare, to state and explain. So here we have to state and explain. We'll say, same charge since number of protons is equal. Okay, next one is comparing nucleus Y and nucleus X. But we are told that nucleus X decays by emitting an alpha particle to form nucleus Y. So from this logic, it is apparent that nucleus Y has 2 less protons, because whenever an alpha particle is produced, an alpha particle, as we should remember, it's a helium nucleus. So whenever it is produced, it means that 2 protons have been removed. So in this case, 2 protons have been removed from X, such that Y has 2 less protons. So since the protons determine the charge of a nucleus, the charge of Y is less than the charge of X. So according to this question, we will answer that it is less than charge of X since Y is 2 protons less. So since Y has 2 protons less, then we expect that the charge of Y is less than the charge of X. And remember, we are considering the nucleus here. We are not even considering the entire atom. So we don't care about the electrons. The electrons would neutralize the protons if it's a neutral atom. So we are only considering the nucleus. Then finally, use the principle of conservation of momentum to explain why nucleus Y cannot be stationary immediately after the decay of nucleus. So immediately after the decay of nucleus X, you're supposed to use the principle of conservation of momentum. So you can never answer a question, especially one where you have been directed on the principle to use, and ignore the principle that they want you to use to explain. Besides, this makes it easy actually for you to know how to answer the question. That is, of course, provided that you know what the principle of conservation of momentum says. So that's the starting point. The principle of conservation of momentum says that the total momentum of a system before collision equal the total momentum of the system after collision. So be that being the case, we know that originally nucleus X was just existing stationary. So by definition for momentum is mass times velocity. So if it was stationary nucleus X at first, then its momentum was 0. So the initial momentum of nucleus X was 0. So if nucleus X splits now to form nucleus Y and the alpha particle, the total momentum of nucleus Y and the alpha particle must also become 0, must also be 0. But however, it is known that the alpha particle, when it is produced, it is not stationary. It will be moving away, the alpha particle, once it is produced. Alpha particles, when they are produced in any experiment, even from IGCSE, you have always known that alpha particles are produced and they move through air, going away. So if the alpha particle is to be moving away, then it means that it has momentum. So if it has momentum, then we have to make sure that the momentum, total momentum, is 0. So to do that one now, the momentum of the nucleus Y must be equal and opposite. Since they are both vector quantities, the momentum of nucleus Y must be equal and opposite to the momentum of the alpha particle, such that when we add these momentums, because the other one is in the opposite direction to the other one, they subtract each other, giving us an answer of 0. So that is the issue here. So the answer would say total momentum before collision, total momentum before collision equals 0. Of course, this is the momentum of X. Then, or let me put it in brackets, momentum of X. So then we say total momentum after collision must be equal to 0. Total momentum after collision must be equal to 0. Now we continue. Since the alpha particle is released with a velocity, then it must have a momentum. So Y must have an equal and opposite momentum. Y is not stationary, because by having momentum, remember momentum is mass times velocity. So if momentum is mass times velocity, then if something has momentum, then it is not